photographers before because I recently got to visit a environmental surveying lab, and one of the things they do there is
Oh,
they analyze soil vapor samples for like commercial properties and things like that. So they do a
wonderful.
lot of gas chromatography to kind of determine the composition of the gas they're working with. So it
Yeah,
was
it's
kind
a
of
very
interesting.
nice, reliable. Oh, good. So you saw that. You are familiar with it. So let me ask you, does it the GC alone, or usually they are working with the GC mass? It's a complete.
Yeah, they use the GCMS. They use a combination.
Exactly, exactly. Absolutely. Even if you were in the lab, you can see it in the video that the machine that we are going to use for GC alone, it's a very old one, so outdated one. So it's good for us because we are going to learn how to get familiar with the basic concept of GC, gas chromatography. That's just the purpose. But I know right now we have lots of better, devices and machine, and we have the GC mass in the lab too, but we are not working on it in Chem 451. They are going to use it for research. So it's a nice one. It's giving us a very good result and data. So it's a very, chromatography. It's a very good one. We haven't talked, guys, about the HPLC yet, right?
No, we
No,
have not.
no.
Uh-huh. Okay, so we are going to have two types of chromatography in this course. The first one that we are going to see is GC right now and HPLC in future. And actually, I can tell for HPLC, we got a new machine. It's a pity that we cannot have hands on it and touch it. That's a nice one. Pretty beautiful, working and precise one, but it's okay. Okay, you are going to see it in the movie. This one, pretty simple to work with. And as you may have seen it, not yet, you are going to see it in the video that we have there. Particularly for this experiment, you are going to find how much is the percentage of ethanol in the gasoline. And actually, they are going to add it. In the US, they are going to add ethanol to gasoline. I believe that's one question. You are going to answer it. It's at the end of this report. We will see that. So this is the goal. This is the aim for experiment, finding how much gasoline, how much ethanol we have in a gasoline sample, unknown sample we were supposed to give to you. So as usual, for all other experiment, we are gonna run a couple of standard sample, different percentage and concentration, getting the standard curve and finding the unknown. This one is again easy peasy, just one standard curve, and you are gonna find out the percentage. But we have to be careful about one part I'm going to tell you when we are going over the data right there. So again, the basic concept of gas chromatography, you can have it in introduction to explain what do we know about the gas chromatography and GC, and how it's going to be run, what is the usage. You can see that briefly. For all chromatography, we are going to have a column. This one is gas because eluent, it's going to be a gas, that base one. And then we are going to inject the sample in the liquid form. But because of the high temperature, that sample, it's going to get converted to the gas, and it's going to move through our eluent. And we are going to detect it with a detector, that how much of each sample we have. We used to run the cube factorial design that you worked in the tutorial at the beginning, but not anymore right now. Even we simplified this experiment for you even more. So basically, we just need to set up some parameter. You can see it right here. Of course, you don't need it. Don't worry about that, because right now you are just using the mock data. So we have a computer as usual. We are going to set the parameter. We are going to have two temperatures right here for this one. 120 and 180, and then it's probing, it's starting when the machine is running. It's starting at 120 degrees Celsius, and then it's gonna reach 180. During this temperature probe, you are gonna collect the graph, the peak right there. And then the solvent that we are gonna use for samples here, it's gonna be hexane. We are gonna use hexane. That's gonna be the sample right here. Guys, can you hear me? I'm so scared and, you know, panic that my
We can hear you.
yeah,
Yeah.
my internet is going off. So because of that, I'm double checking with you that if you can hear me or not, all those. Okay.
We'll let
So
you know
thank
if
God.
it changes,
So far-
if it cuts out.
Yes, so far so good. Okay. Yeah. So we are gonna have hexane. So basically you are gonna make a set of solution of ethanol in hexane. So starting from 5 microliter, adding to 1 milliliter. Actually, you know, guys, solution making even for this one, it was so easy because we were giving you a microtiter pipette and a small, even we were not using the volumetric flask. It was just a small container. You were mixing those, and then that's it. Pretty easy solution making. And then we were running all those solution, and actually each solution 3 times. You will see that in the data set. For example, just the blank that is going to be only hexane, the solvent that we have, 3 times, and then each sample 3 times to collect the data. And then we were done with collecting those, and then you are going to have the peaks and get ready for the calculation. For calculation, when we are going to go to the peak, I'm going to switch. Actually, look at here, guys, what you need to have in your report right here. So how does GC work? Of course, this one is going to go into introduction and why ethanol is added to gasoline. All this question can be answered easily in your introduction. Then report volume percent of ethanol. Make sure you are reporting in percentage. This one, it's going to be in result and calculation for us. And then finally, you are going to find out LOD and LOQ right here for me. These are the calculation you need to do. And then let's go take a look at the data that we have right there. And actually this one, it's a beautiful one because we are going to give you the pics, the graphs. So take a look right here, please. As you can see, the first one we are starting, you can see under it, it says 0 ethanol, trial 1. Means what? Means first sample, we are just gonna run the hexane. So, of course, be familiar with these peaks. When you have just hexane, means no ethanol present in this sample. So these 2 peaks that you see right here, they are just going to be pure hexane. You need this data specifically when you are going to find the usefully in LOD and LOQ right there, when you want to find out the sigma. And then, of course, as I told you, each sample, 3 trials right there. Guys, take a look at the table that we have in the graph. You will see that right there. It says, can someone tell me what is a little bit weird with that table?
It looks like there's 4 values for area, but only 3 for, is that retention? And
No,
height?
actually we have 3. Look at right here. The first peak, I cannot mark it right here, unfortunately. So the first peak on the left, the second one, and teeny tiny small one on the right. And we have the total area right there. Maybe something else. Something else doesn't make sense in that table. Let's pay attention. Any guess?
Is it the unit?
Can we see the slide? Can we see the page, guys, right now?
Yeah.
Yeah, I can see it again.
Okay. Okay, good. Something in
So-
there, something in the small box of data, the table. Guys, does it
This
say
is-
on the left side heptane C? Hept C.
Oh, is that what that says? Sorry, it was a little like blurry.
I didn't talk anything about the heptane, right?
Correct, yeah.
So don't get confused. Sorry, guys. This is bad. This is bad part on us because the computer, the program hasn't been changed for this part, particularly for new experiment that it's going to be ethanol in hexane. Previously, we used to work on the different isomers of heptane. So this is from there. Ignore it. That one doesn't, I'm just explaining it. And when you are going to be at home and you are going to take a look at data, you are not going to get confused. Oh, where the hell this heptane C is coming from?
Okay.
Is that clear right now?
Yeah.
Wonderful. So you are going to have the most important number. You are going to focus from this table. It's the area because you need that one for making the standard curve. So we saw that we have 3 trials for just hexane 0 ethanol. Right here, as you can see, 50 microliter ethanol, trial 1. Guys, can you recognize where do we see ethanol? Which peak it's belonging to ethanol? Because again, in that table, you will see that the compartment part, it's not right labeled. We don't have any heptane B, heptane A. So you need to recognize which peak is which. Can you please tell me which one is going to be ethanol in this one? Because when we start working with the peaks that it's containing ethanol, that one is important for us.
Isn't
So
that
that
the
one
largest
is-
peak?
So see, this is a confusing part. The largest peak that you see in the middle, those two, we saw that in where? Right here, pure hexane. Isn't that hexane?
That's hexane, yeah, just by itself.
Exactly. So when we are running our true sample, when, for example, we are running 50 microliter of ethanol in hexane, you still see those hexane peak because your solvent is giving you peak in GC. But where is ethanol? Then you can compare this peak with the top one. This one is not the best one. See, guys, for example, remember, guys, if you see you don't have a good set of data, if you see you don't have a good trial, guys, you don't need to include it in your averaging. For example, take a look at trial 340 ethanol. I don't like this one because the peaks, they are not separated from each other. They are not distinct. So let's go back right here. Again, let's take a look. When you have a pure hexane, how many peaks do you see there?
We see 2 peaks. Or
Two major peaks. A small, teeny, tiny on the right side. If you take a look at, the number, it doesn't matter. At retention, actually, right there. So, see, we are going to have retention 0.650, a very small one. This might be a little bit remaining of previous ethanol in the machine, but the 2 major peaks, we are going to have it at retention 1.216 and 1.466. So these are the hexane. Right now, when we are coming here, you are going to see what? See, guys, 0.516, that it was a small, teeny, tiny area, it's still there. But we have a new one showing up right here. At what retention, guys? Address it to me, please.
The 1.
Exactly. So is this the ethanol? Guys, you need to recognize it. I'm just helping you.
I would still go with the 0.516.
I was going to go to 2.
0.516, we had it in hexane alone. It's getting repeated here. It's not something new, right?
That's right.
So we should look for something new because we have ethanol right now. So
But
that's
it wouldn't be the two major peaks because we found those in hexane.
those are the
already,
hexane.
correct?
So okay, our best guess it's 1, right, at retention. 1
Right,
minute.
because that's not
Then
consistent. Yeah.
let's scroll down. So this is trial 2, trial 3 right here. And then let's go to the next concentration, 100. Agree, guys?
100 microliters.
Exactly.
Okay. Then that small peak on the left side would be the ethanol then, because in this.
So see, right now, which one is staying unchanged? Those 2 peaks on the right, that they are hexane. Of course, we didn't touch anything about that. But the very left side one, it got bigger according to the area. So this one is ethanol increasing concentration. It's going to give the bigger peak right there, as you can see. And even if we scroll down more, you will see that you are going to have it again right there. So that one is going to be ethanol on the left one. I'm telling this one to you because I don't want you find the wrong number in the area on the data table and all your calculation goes wrong. Okay, we make sure we see the ethanol right there. Guys, again, especially particularly for GC, if you see some numbers, they are not close enough, don't worry, don't include that one in your averaging because it's going to make your average completely off. Because again, remember, this is the mock data, this is the real data. Everything it depends on, for example, how precisely, please watch the video carefully. The syringe that we are going to use for GC is going to be tiny small one. We are going to inject 3 microliter inside this machine. So a little bit change, it's going to make a big difference. You know what I mean? And even when we are doing it faster or later, so that one is changing all parameters for us. So please make sure you are choosing the closed data and get average for your calculation. Are we good so far, everybody?
Yeah, it's making sense.
Absolutely. So get average for each trial. You have the unknown sample right here. Make the standard curve and find out what is the percentage of ethanol in your sample. Basically, that's it. And find out the LOQ and LOD.
Do you want us to include standard deviations as well?
Yes, please.
If you look in the.
You need it because you need it in the formula of limit of detection.
Right.
It is coming anyway. Yeah, absolutely.
Just confirming.
Yes, no worries. I'm here for that. So any more question, everybody?
Nope, all good.
Sounds good.
So as usual, start working on it. If you have more question, I'm glad I could connect it actually, guys. I was so worried. So right now I'm happy. So if you have any more question, Wednesday again at 10, we are going to be here. Because sometimes when you start working on the lab report, then some questions are popping up. Right?
Correct.
Right.
So don't worry, I'm going to be here. Any question for me, everybody?
Nope.
Are we able to just cut and paste these screenshots of the charts into our lab report? Like the ones that we had, I think it was for the second module?
I think so, because I think this one is going to be, again, a PDF. You should be able to do that. But, you know, guys, let's do one thing. I don't need all these, pics in the lab report. What you are going to do, you are going to make a beautiful table with all data together, okay?
Okay, so we don't need to include these pictures. We can
No,
just
you
include
don't
the
need
table.
for this one. So give me a complete data, table of data, and then standard curve based on that data you are using. But please, if you are emitting any data point, make sure to explain that one, please. Or any graph that you don't use. Okay, any graph, for example, like this one that you don't like it, you are not going to use it. Please make sure to mention that one in your result and discussion.
Appreciate it. Thank you.
Goody. Any more question? Everything is good, guys.
Yeah, this one's a straightforward lab.
It is. You saw that. It's a pretty easy one.
Yeah,
Fast and easy, straightforward. This is the easiest one.
Yeah, I'm already
It's
on the results
definitely a nice
discussion.
break from the last one for sure.
Absolutely. See, Dr. Tuyan is nice. So she's giving us, she said right after fluorescence that we are so tired of all those graphs, you know. But guys, just imagine if you were doing fluorescence by yourself in the lab, how stressful could be, because most of the time a student cannot even reach the quencher one.
It was crazy enough to spend all that time consolidating all that data into one graph.
Imagine in the lab you are going to collect those, and we are making a small teeny tiny solution in a small flask, so the possibility of making a mistake, it was so high. If a student, they were making a mistake in one set of data, they had to repeat it, and imagine how much that one was putting them behind. Oh my God, that one was a very long, lab. So if a student, they were not making any mistake, 4 days completely with the quencher one. But if they were making a mistake, oh my God, that one was. So maybe sometimes online one is not that bad. Maybe it wasn't bad. I know online teaching and learning it's stressful, but not for fluorescence, guys. Are we good?
It seems straightforward.
This one is nice. This one is nice. So enjoy it, guys. And if you have any more question, so I'm gonna be in Zoom on Wednesday. Sounds good?
Really appreciate it. Thank you.
Thank you for joining me. Have a nice rest of the day, guys. May see you on Wednesday, may not for this one. It's up to you. I'm gonna be here.
Thank you so much.
I had a quick, I was just a little information, but I was a little late, Margin. For some reason, I remember you saying that we weren't going to meet today.
Oh, no, I said I'm going to be out of country, but we are going to meet.
Yeah, I remember you said that, but I thought you were going to put a late record, like a pre-recorded thing.
Oh,
up.
actually, I said if I cannot hold the Zoom, if you know, because right now here, I'm coming to the Zoom with VPN. I wasn't sure if everything is working right now because, it's filtered right here. The Zoom is filtered. So sorry about that. Still on misunderstanding.
No, it's all good. I was only like 2 minutes late. I'm already on the results and discussion for this lab. I started on it last night. But
wonderful.
I didn't know if we were gonna get docked points or anything if we showed up late.
Oh no, don't worry. No, not for that one. No.
Okay, cool.
You will hear no, don't worry about that one. You will hear most of the time.
I'm here all the time.
Yes, absolutely. So the most important one was talking about the data. You saw that. Showing the pics and how we are going to handle it. So that one, no, don't worry about it.
Okay, cool. Awesome. Thank you, Margin. If anything, I'll see you on Wednesday.
Okay, absolutely. Thank you so much, guys, joining me. So enjoy your day. Have a good day.